Hi friends, welcome back to Team Education. In this video we are solving double integral f of x comma y dx dy where x is a function of y or else y is a function of x alone. Okay, now you see the given problem is integral 0 to 2 integral 0 to square root of 2x xy dy dx. Observe the second problem is one of the limit is one of the integral is having finite limits, another one is a function of y. Here one of the limit is finite, another one is a function of y. Here one limit is finite, another limit is function of x. Here one limit is a finite and another limit is function of x. So by the observation you can say these double integrals. Now what we are doing means the double integral of f of x comma y with respect to x and y. Here one function is in terms of other variable and another variable we are treating as a constant. So this is, you can say, type 2 evolution of double integral type 2. What is type 1? Type 1 we are discussed in earlier video. I will explain. I will give the difference between type 1 and type 2 clearly. You see, integral a to b integral c to d f of x comma y dy dx. This is a type 1. This is a type 1. Type 1 means here both limits are x limit and y limit. This is a limit of y and this is limit of x. Both y limit and x limits are constant. Okay. Next, in the type 2 you observe here one limit is with 0 to 2. Another limit is 0 to root of 2x. So can you say this is a function of x? Yes. So y is equal to f of x to f1 of x to y is equal to f2 of x. Here you can say y is over. See, this is the limit for y. And what about this? These are limits of x. So x limit is from 0 to 2. So this is type 2. Type 2 is nothing but here x is from a to b and y is equal to f1 of x to y is equal to f2 of x. Are you understood? May they will give like in this one. You see, observe the second one. Limit of these are limit for what? X, and these are limit for y. So x is a function of y here and y is a constant, nothing but y is equal to y1 and y is equal to y2. But x is here function f1 of y and x is equal to f2 of y. So how to evaluate these type of the problems now we are discussing, and we will solve each problem, right? Type 2 model 1, you see, integral a to b integral f1 of x to f2 of x f of x comma y dy dx if they are given. Now you have to observe. So whenever function is in terms of x, you can say that is limit of y. Whenever a function is in terms of y, suppose function is in terms of y, then you can say that is limit of x. If the function is in terms of x, then you can say function is that is limit of what? Y. So your function is in terms of x, so you can say these are limits for y. Limits for y. Then obviously the remaining is what? Limits of x. So in this case what you have to do means first we have to integrate f of x comma y with respect to y, and you have to apply the upper limit and lower limit. Then you will get a function in terms of x alone. Function in terms of x alone. Now you have to integrate with respect to x. Then you will get a constant only. Constant I am treating as a k. Are you understood here method 1? Now coming to the method 2. Method 2 is in the form of y is equal to a to b and x is from f1 of y to f2 of y. f1 of y to f2 of y. The integrand is f of x comma y dx dy. Here you see function is in terms of x or y here. Function is in terms of y. So you can say these are limits of x or y. If the function is in terms of y, then that is the limit for x. If the function is in terms of x, then that is the limit for y. So now this is the function of x only, na? So obviously this is also function of x. Then obviously it will become a to b is a function of limits for y. f1 of y and f2 of y are functions of y, so limits for x. Now in this case, first what we have to do means we have to integrate with respect to x, and if you are applied the upper limit and lower limit, then you will get a function in terms of y. Okay, now x will be converted into y terms now. Then pi of y is from a to b dy. If you simplify this, then after integration with respect to y, if you substituted upper limit and lower limit, then you will get a constant k. This is the procedure. In this type 2, for double integration, we have to do like this. Even for triple integral also same thing only. But in this video, we are discussing solutions of double integration. We are evaluating the double integrals, that to type 2. The first problem is integral 0 to 2 integral square root of 2x xy, integrand is xy dy dx. So first we have to integrate with respect to y, right? Now integral 0 to 2 x is, we have to treat as a independent, that is a constant. Now y integration is y square by 2, limits from 0 to root x, root of 2x, okay, into dx. 1 by 2 I can write outside. Then integral 0 to 2 x into upper limit minus lower limit, f of b minus f of a form. So square root of 2x will become 2x minus 0 into dx. So this is equal to 1 by 2 times of 2 will come outside. Then integral 0 to 2 x into x square dx. So 2 getting cancelled. Integral of x square means x cube by 3, limits from 0 to 2. So what you are getting here, 8 by 3 minus 0 by 3, that is nothing but answer is 8 by 3. Is it clear for everyone? First problem is completed. Now coming to the second problem. Evaluate integral 0 to log 8 integral 0 to log y e to the power of x plus y dx dy. Now it is in the form of integral a to b integral, this is in terms of y, so f2 of y. So in the lower limit you can consider as f1 of y, f of x comma y dx dy form. So first we have to integrate with respect to what? X, and then after applying upper limit and lower limit, then you will get a function in terms of y, and you have to integrate this pi of y with respect to y. Then after applying upper limit and lower limit, you will get the constant k. Okay, coming to this is, you have integral 0 to log 8 and 0 to log y. So you can consider these are limit for x and these are limit for y. E to the power of x plus y, I can write as e power x into e power y into dx dy. So first we have to integrate with respect to what? X alone. So with respect to x is here, you have e power x. So integral y is equal to 0 to log 8 e power y, I am keeping left side. Now e power x integration is e power x. Now the lower limit of x is 0 and upper limit of x is log y into dy. So if you are substituted upper limit and lower limit, now apply the f of b minus f of a form, e to the power of log y minus e power 0 into dy. So integral 0 to log 8 integral 0 to log 8 e to the power of y. You see here e and log getting cancelled, then you will have y minus 1 into dy. Now you observe product of two functions here, which is algebraic function. This is an algebraic function, so you consider this as u and this as v. Now you have integral uv dx by Leibniz method, u v1 minus u dash v2 plus u double dash v3, so on u v1. v1 is nothing but integration of v, first integration of v. v2 is nothing but second time integration. v3 is nothing but 3 times integration of v. Triple time we are integrating v. Now u dash is nothing but first derivative. U double dash is nothing but second derivative. Dash or prime. Okay, based on the authors, they will call a dash, or some authors they will call u prime. Prime or dash, both are differentiation only. Now, so here I am applying UV rule. This is called a Leibniz rule, or else integral by parts also you can say. Now first term u into y minus 1 into v1. v1 means e to the power of y. See, this is u, this is v1, this is u, this is v1, minus u dash, y minus 1 derivative, y derivative 1 minus 1 derivative 0. So simply I am writing 1 only. So this is what? U prime. Now v1 integration is v2 na? So v1 again integration is v2, that's it, plus u double dash. U double dash means 1 derivative is 0, so no need to write this concept. Up to this you can up to this only you can write. Later on a higher derivative will become what? 0 only na? So no need to write. Now lower limit is 0 and upper limit of y is 8, log 8. Now substitute upper limit and lower limit, then you will have, you see, first here I am simplifying, later I will write this is y e to the power of y minus e power y minus e power y. So minus e power y means can I write minus 2 e power y? I will write again y e to the power of y. This is minus e power y. 1 into e power y means also e power y only na? So minus of minus plus, that is 2 e power y. Limits are 0 to log 8. Now you apply the upper limit, that is log 8 into e to the power of log 8 minus 2 e to the power of log 8. This is upper limit minus lower limit if you substituted 0 into e power 0. 0 minus 2 into e power 0 is 1. So now if you simplify this, then you will have this is log 8. E power log 8 is nothing but 8 only, na? E and log getting cancelled, then 8 minus 2 into log e power log 8 means 2 into 8 only you will have, minus of minus plus 2. So this is equal to 8 log 8. This is minus 16 plus 2. Minus 16 plus 2 is how much? Minus 14. That's it. This is the second problem. Now coming to the third problem. Evaluate. Third problem is evaluate integral 0 to a integral 0 to square root of a square minus x square dx dy. Here integrand they are not given anything. That is nothing but default. What is the integrand here? F of x comma y is equal to 1 only. 1 into dx dy is nothing but dx dy only, na? Yes. So here you observe. Tell me the limits of x and y here. First I am writing 0 to a. Later on 0 to a square minus y square dx dy. So can you guess this is the function of what? Y. Function of y means limits of x. So x is equal to 0 to this one. And the remaining term what you have? X is completed, na? Now another variable what I have? Y only. So this is limit for y. Y is independent. X is a dependent on y. So first we have to integrate with respect to what? X. Now if you are integrated with respect to x, first you see y limits are 0 to a. Is there any term here? Means nothing. Default, that is 1 only. So 1 integration is with respect to x is x. Now the lower limit of x is 0 and upper limit of x is a square minus y square into dy. This is equal to integral 0 to a, y is equal to 0 to a. If you substituted upper limit, then you will have square root of a square minus y square minus lower limit if you substituted 0. So no need to write into dy. Now here you observe integral of a square minus y square. Here in this case you see you will have a formula, but why we have to use the formula I will explain here. You see this square root of a square minus x square, can I write a square minus y square whole power 1 by 2? Yes. Integral dy, na? Do you remember here x power 1 by 2 dx? X power 1 by 2 dx means this is in the form of x power n dx. So what is x power n integration? X power n plus 1 by n plus 1. So can you apply a square minus y square power 1 by 2 plus 1 by 1 by 2 plus 1? No, we cannot apply. Why we cannot apply means if you observe this a square minus y square whole power 1 by 2, we have to compare with we should not compare with only x power n dx, because this x power n dx you can write as x power n into 1 into dx. I am comparing this x power n into 1, that is you see f of x power n into f dash of x dx. You observe integral x power n into 1 dx. You see in place of f of x I have x. So f of x derivative is 1. So f of x derivative is f dash of x, that is beside. Now x derivative is 1, that is beside. But is a square minus x square derivative is beside? Check it here. A square minus y square derivative is what? Minus 2y. Is minus 2y is beside here? No. If minus 2y is beside, then you can apply this formula. Which formula? F of x power n plus 1 by n plus 1 formula you can apply. But you don't have a f of x power n derivative beside, that is f dash of x. So you cannot apply this method. So we have to go for formula. Which formula you have? You have to remember this formula. We have integral square root of a square minus x square dx is equal to x by 2 square root of a square minus x square plus a square by 2 sine inverse x by a. Friends, you have to remember this formula. Why we are applying this formula? Why we cannot apply power n plus 1 by power n plus 1 formula? Is it clear for everyone? Right. Now, so in place of x what I have here? Y only. So just replace x by y. Then you will have x is y by 2 square root of a square minus y square plus a square by 2 sine inverse of y by a. Now you have to apply the lower limit of y and lower limit of y is 0, upper limit of y is e. Now upper limit minus lower limit na f of b minus f of a. In place of y we have to substitute a, later we have to put in place of y 0. So if you are applied the upper limit, then you will have a by 2 times of a square minus a square. What is a square minus a square? 0. Square root of 0 is 0 plus a square by 2 sine inverse of a by a. A by a getting cancelled means sine inverse 1. This is upper limit minus lower limit. You observe, if you put y is equal to 0, 0 into this term non-zero, obviously what? 0 plus a square by 2 times of sine inverse 0. Sine inverse 0 is 0 only na? So 0. Now on simplifying, here what you are getting, you see, a square by 2 sine inverse 1. But sine inverse 1, how you can express means sine inverse is sine inverse. One value in terms of sine we need to write, because sine and sine inverse getting cancelled. So if you written in angle, simply sine 0 is 0, sine pi by 3, sine pi by 6 or sine pi by 4 or sine pi by 2. Yes, sine 90 is equal to 1. So sine inverse getting cancelled. Then you will have a square by 2 into pi by 2. So the answer is a square pi by 4. The value of integral 0 to a, integral 0 to a, integral 0 to a square minus y square dx is what? Pi a square by 4. Now coming to the fourth problem. Given problem is evaluate integral 0 to 1, integral 0 to x square e power y by x dy dx. So here integrand is e power y by x. So this is a function of x comma y. Now here you observe the limit 1 is 0 to 1. So you cannot say directly 0 to 1 is a function of limits of x or y, you cannot say, because this is independent. Next, here 0 to x square. 0 to x square is nothing but x square is a function of x. So obviously it is a limit of y. Limit of y. So you can say these are limit of y, and 0 to 1 is a limit of x. So first we have to integrate with respect to what? Y, because y is a dependent on x. So integral 0 to 1. First, if you are integrated e power y by x with respect to y, we are doing e power y by x integration is e power bracket is e power bracket by bracket derivative is how much? 1 by x into dx. So the limits of y are here 0 to x square. Now we have to simplify this one, integral 0 to 1. So can I write this as x into e to the power of y by x? The limits are 0 to x square dx. So this is equal to integral 0 to 1, upper limit minus lower limit na. In place of y only you have to substitute x square. So x into e to the power of x square by x means x minus lower limit if you substituted e power 0. E power 0 is 1 into dx. Now here also you observe this is in the form of UV rule or not. So which is algebraic function here you have? This is algebraic function and this is exponential function. So you consider algebraic function as a u and this is v. Now you know the formula, integral by parts or by Leibniz test, integral uv dx is equal to u v1 minus u prime v2 plus u double dash u dash v2 plus u double dash v3 and so on. v1, v2, v3 are indicates integration, first integration, second integration, third integrations of v respectively, and u dash, u double dash is represent u and first derivative of u, second derivative of u and so on respectively. Now I am simplifying this directly here I am writing. So uv rule means u is x into v1. v1 means integral of e power x minus 1 is e power x integration is e power x minus 1 integration with respect to x is what? X. 1 integrate x. Okay. Minus u dash. This is u. This is v1 na? U dash. U dash is nothing but x derivative 1 and v2. v2 is nothing but e power x integration is e power x minus x integration is x square by 2. Next plus u double dash. U double dash is 0. One derivative is 0. So you no need to take the next terms also. So close the bracket. Now the limits of what limits of x what you have? 0 to 1. Now we have to substitute upper limit and lower limit. In this case, if you substitute upper limit 1 into e power 1 is e minus x is 1 minus here if you substitute this is you observe e power 1 minus 1 by 2. Okay, this is upper limit minus lower limit is if you put x is equal to 0, 0 into this term will become 0 minus here if you substitute 0 e power 0 is 1 minus 0, that's it. Now you see, on simplifying, e minus 1 minus e minus of minus plus 1 by 2 minus of minus plus 1. So minus 1 plus 1 getting cancelled, plus e minus e getting cancelled. So the answer is 1 by 2. So the value of integral 0 to 1, integral 0 to 1, integral 0 to x square e to the power of I by x dy dx is how much? 1 by 2. Next, last problem. Evaluate integral 1 to 2, integral 0 to x dy dx by x square y square. So here you observe one limit is independent and another one is dependent. In the dependent, lower limit is 0 and upper limit is x. So it is a function of x. Function of x is nothing but limit for what? X or y? Y only. So this is limit for y, and obviously the remaining is limit for x. So y is a function of x. So first we have to integrate with respect to what? Y only. Na? Now before that, you observe, I am writing simply this as integral x is equal to 1 to 2 and y is equal to 0 to x 1 by x square plus y square into dy dx. So first we are integrating with respect to y. While integrating with respect to y, here you observe 1 by x square plus y square is a function of x and y. If you are integrating with respect to y, we have to treat other variable as a constant only. But here you observe numerator is there, denominator is there. Is denominator derivative in the numerator? No. Is y square derivative in the numerator? 2y is there? No. If the denominator derivative in the numerator, then you will use log of denominator, right? But here you don't have that one. So you have to go for a formula. Which formula you have to apply? So we have a formula. If integral 1 by x square plus a square dx is equal to 1 by a tan inverse x by a. Okay, integral of 1 by x square plus a square dx is equal to 1 by a tan inverse x by a formula we will use. Here in place of x what I have? Y, and this is a constant. X you can treat as x is here constant and y is a function of x, and meaning of course if you written this is 1 by x square plus y square dy na, we are integrating with respect to y, so x is a constant. So what you will get here? 1 by x tan inverse y by x. That's it. So I am writing here first integral x is equal to 1 to 2. Then what is the integration of this? You have 1 by x tan inverse y by x. Now the lower limit of y is 0 and the upper limit is x into dx. Integral x is equal to 1 to 2, 1 by x. In place of y you have to substitute upper limit and lower limit. Na? So if you substituted upper limit, then you will have tan inverse of x by x means 1 minus if you substituted lower limit, then tan inverse 0 into dx. So integral x is equal to 1 to 2, 1 by x into tan inverse. Whenever inverse is there, so 1 can you write in terms of tan means? Yes. What you can write here? Tan, how much? Tan, which value is 1 here? Pi by 4. Tan pi by 4. Tan 0, tan inverse 0 is nothing but tan 0. Tan inverse getting cancelled. Then you will have 0 only. So I am not writing. Into dx. So tan inverse getting cancelled. So you will have pi by 4. Pi by 4 you can write left side because that is a constant only. Na? So pi by 4 times of integral x is equal to 1 to 2, 1 by x dx. So here you have pi by 4, 1 by x integration is. Now you observe denominator x you have, numerator 1 you have. This is like a numerator and denominator is there. So we have a formula integral f dash of x by f of x into dx. That is denominator derivative in the numerator. Then you will have log of mod f or else log x. Log of denominator you can write simply. So log x. So what are the limits of x? Lower limit is x is equal to 1, upper limit is 2. So substitute the lower limit and upper limit. Then first of all pi by 4, upper limit f of b means log 2, f of a means log 1. So pi by 4 times of, here what you will get here? Log 2. So log 1 is 0 na. So what is the answer? Pi by 4 times of log 2. Hence integral x is equal to 1 to 2, integral y is equal to 0 to x, 1 by x square plus y square dy dx is equal to pi by 4 times of log 2. Okay friends, so in this video we are clearly solve the problems based on type 2, multiple integrals type 2. So in the next video we will discuss the problems double integral over r x square plus y square dx dy over the region r, where r is a region bounded by positive quadrant for which x plus y less than or is equal to 1. And the second problem is evaluate double integral over r x square y square dx dy where r is a region bounded by the unit circle x square plus y square is equal to 1. Observe the type 2 and type 1. Type 1 and type 2 both are having limit, but this is a type 3. Here they are not given limits, so they are given a region. So we need to find the limits first. After that we have to do the integration like type 2 or type 3. So when you will get type 1 means if the given region is a square or rectangle, then you will get a, or else maybe cuboid also for the triple integral, you will get a type 1. When you will get type 2 means if rest of these four, that is either if it is not a square or rectangle, cuboid, then other rest of all other cases you will go for type 2. So first we need to find the limits for this region, and then you can do these problems by using the previous methods. Okay, thank you for watching this video.